Hi everyone. In today's video, we're diving into circles. So we're going to start by revisiting the key formulas for circumference and area of a circle, and then see how those same ideas help us find the length of an arc and the area of a sector, both parts of a circle that you can see anywhere really. Stick around until the end as well for a quick MYP eAssessment style challenge to test your understanding. It's all about applying what you've learned to a real life context. Okay, but first of all, we have a question here that says, find the area and circumference of this circle in terms of pi. Now you'll see in the top right hand corner, we have our two formulas. These are the formulas given to you in the MYP eAssessment in the formula booklet. So do make sure you refer to them when required. Okay, don't forget that they are there. So the first thing I'm going to do is the area. So I'm using the formula area equals pi r squared. Now r is the radius. So for this particular circle, the area is equal to pi multiplied by 9 squared. Okay, so my area is going to be equal to 81 pi. Okay, remember your units. We're talking about centimeters. And if it's area, it's going to be centimeters squared. Okay, now this question asks for me to leave this in terms of pi, which is why we've got pi in the answer. If it asked you for 3 significant figures, you would need to convert this into a decimal answer. So you can just use the calculator for that. Okay. So moving on, we now want to find the circumference of the circle. So the circumference, okay, is equal to 2 pi r. Okay, so here we've got 2 pi, lots of the radius, which is 9. Okay, so overall this would be equal to 18 pi centimeters. I'm being very lazy there, sorry, and not writing out circumference 3 times, but that would be our circumference. Before moving on to questions regarding arcs and sectors, I just want to draw your attention to the formulas that you need to know, or at least you need to know how to adapt the formulas for the circle, okay, to be able to find your arc length and sector. So if you just take a look at the pink box here, we have our formula for arc length, which is equal to theta over 360 multiplied by 2 pi r. Okay, so it's very similar to the circumference. Okay, we still have our 2 pi r in the formula, but the theta over the 360 is the proportion of the circle that you've got. Okay, so in a full circle, we have 360 degrees. For a arc length, we only have part of the circle. Okay, so you need to know what that angle is for the arc length that you have. Okay. Same thing for the sector area. So we have theta over 360 again. We're looking at the proportion of the circle that you have, and we are multiplying it by pi r squared. Now again, that's remained the same from the area of a circle. Okay, so the main thing that you need to remember is you can use both of the formulas available to you from the formula booklet. You just need to remember that if it's arc length or sector area, you need to multiply by the angle out of 360. Okay, we will put that into practice now so that you can understand this a little bit more. Here is our first example of finding the area of a sector. So this question wants us to find the area of sector PQ, and we want to give our answer to 3 significant figures. Okay, so for area of a sector, I need my area of a circle formula, and I'm multiplying by theta over 360. Okay, so I'm using this formula here. So what does that really look like? Well, the angle in this question is 40, and so I write that out of 360, and I am multiplying by pi times the radius, which is 8, all squared. Okay, you can put a multiplication in there if it helps you to understand what that means, and this will be the sector area. Okay, so you're going to put that into your calculator. So sector area is going to be equal to 22.3402. Now, that would be meters squared. However, I'm asked in the question to give the answer to 3 significant figures. Okay, so if I take a quick look at my answer, I'm going to count the first 3 figures that are significant, okay? Draw my line, look next door, I've got a 4, so I'm going to round down, okay? So this answer will approximate to 22.3 meters squared, okay? And then we have our answer for the sector area. Now we are moving on to a question about the length of arc XY, and we want to find this in terms of pi and as a number to 2 decimal places. Okay, so the formula that I'm using this time is arc length. Okay, so we want theta over 360. So arc length is going to be equal to 30 over 360. And then I am multiplying by 2 times pi times the radius, which is 6. Okay, so to leave this in terms of pi, first of all, okay, I would have 1/12 multiplied by 2 multiplied by 6, okay, which gives me 1. So it would be 1 multiplied by pi, okay, therefore just pi centimeters for the arc length. Let me just duplicate this a couple of times just for our working. Okay, and then it wants me to convert this to a decimal. Okay, so you would now, in terms of your calculation, add pi back in on your calculator, or just find out what the decimal answer for pi actually is. Okay, and for the 2 decimal places, it approximates to 3.14 centimeters. Okay, so there you have your arc length as well in terms of pi and also in terms of a numerical value. Okay, if you've made it this far, thanks for sticking around. We are now on to our eAssessment practice question. So here we have a gardener is designing a flower bed in the shape of a circular sector. The flower bed has a radius of 8 meters and measures 1/4 of a full circle. To install a border around the curved edge, the gardener needs to know the length of the arc. Calculate the arc length of the flower bed. And then for part B, the gardener will cover the flower bed with compost. Calculate the area of ground the flower bed covers. Okay, so we need to first of all calculate the arc length. And then for part B, we are going to find the area of the flower bed, so the area of the sector. Okay, so arc length, the formula that we need to use is theta over 360 multiplied by 2 pi r. Okay, so theta in this case, now we are told that the flower bed measures 1/4 of a full circle. Okay, so if we have 1/4 of a full turn, we should know that that is 90 out of 360, and we are multiplying by 2 times pi times the radius, which we are told is 8 meters. Okay, you're going to pop that into your calculator, and you would get 12.5663, and it does go on. Okay, now here we're not told to leave it in terms of pi, so your best the best thing to do is 3 significant figures, okay? And you're going to approximate to 3 significant figures. So if you're unsure how to do that, you count the first 3 figures that are non-zeros. You are drawing your line after the 3. We look next door, it's a 6, so it's going to round up. So this time it will approximate to 12.6 meters, okay? And that's for the arc length. Okay, then on to part B, so the area of the sector. So again, we've still got the same angle out of 360, but this time we're multiplying by pi r squared, so pi times the radius squared. Now the radius is 8 meters, so 8 squared, okay? And that's going to be equal to 50.265. It continues. So again, we want to approximate this to 3 significant figures. So 1, 2, 3, draw my line. 6 is next door, so that rounds up to 50.3 meters squared. Okay, so remember, arc length will be units of measure that are not squared, and then area of a sector or anything with area, your units must be squared. Okay, let me know if you have any questions. I'm more than happy to help.